In this project, we built an AI that plays Rush Game, a classic traffic jam puzzle. You'll find how search algorithms like BFS, IDS, UCS, and A-star search help the red car break free, and we wrapped it in a graphical game interface. Let's dive in. Rush Hour is a game where your goal is to get the red car out of a jam grid. It might look like a game, but it's a perfect AI challenge. The problem is a state space search problem. Every move is a node, and AI must find the shortest path to the goal. Each car is a data class that holds its position, direction, and size. The AI uses that to generate possible moves and new states, or nodes. These states form a graph, and our job is to search that graph to find a goal. We use Pygame and Python to build this interactive GUI, and classic AI search algorithms like BFS, IDS, UCS, and A-star search to power the solver behind the scenes. Let's start with the main menu. You've noticed a desert theme background with cactus and a red car, making it feel like a road trip. You can click on Play, Instruction, Credits, or Quit, and Settings. In the instruction, you'll find everything you need to know on how to play the game. On Credits, the game is our team effort for CSC 14003, Introduction to AI. Special thanks to our professor for their guidance. Click on the gear icon to open settings, where you can toggle sound and music on and off. Now when you click play, you'll be asked to choose between custom or default map. And in the default mode, select a level from 3 difficulties: easy, medium, or hard. There are 15 levels in total. And before starting, you'll see a preview of the level layout. You can click Start to begin or back to choose a different level. Now let's check out the solver screen. It's where the magic happens. You see algorithm buttons at the bottom. Statistics like step count and total cost are on the side. And when you solve it, this red car escapes with a cute animation. The solver screen uses a 6x6 grid drawn with Pygame rectangles. We overlay car sprite based on their ID, size, and direction using a helper class called car sprite. Everything is event-driven, button clicks are handled frame by frame. To present algorithm functionalities, I'm going to demonstrate 4 levels, each solved with our corresponding algorithms: BFS, IDS, UCS, and A-star search. Let's try solving level 1 with BFS. You just click this button, BFS, and watch how it moves step by step, updating the board. We see the states update here, and finally, there goes the red car and our victory pop-up. Right, now we can go back and move on to the next level, which is level 5 with IDS as the solution. And our victory pop-up. All right, now let's go back and let's solve level 10 using UCS. Okay. You will notice how it explores more carefully, step by step. Additionally, you may consider choosing the pause, reset features depending on your needs. We have our victory. Now let's go back to the menu screen. And last but not least, let's go level 15 with A-star search. When we run the algorithms, it launches a new thread to solve, so the GUI doesn't freeze. If we press A-star, for instance, then inside that thread, the algorithm explains states using a min heap based on the evaluation function, which is cost and heuristic. We measure how many nodes are expanded and how long it took. Right, and there is our victory pop-up. Now let's try level 15 again, but now with IDS. So IDS has a natural timeout risk because of the limited max depth. So if after all depth level IDS doesn't find a path, we return none. That triggers a failure pop-up telling us the map isn't solvable. Right. Just like you can see here. Now let's dive into one of our added features, a custom map creation. Okay, you can immediately notice the instruction to follow at the top. So according to the rules, the goal car must be oriented horizontally and occupy the same row as the gate. So I'm placing the target car and now pick a color, direction, horizontal or vertical, and length, either 2 or 3 units, and click OK to place the car when you have chosen the position on the grid. Now when you're done, click Complete to start solving. Right. So now let's try another map. We define a grid matrix and fill it in using the car placement. Each car is stored with either row and column, then translated to screen coordinates when drawing. And so I'm placing the target car here and up a wrong placement. So that is the work of internal logic checks for each cell in the grid. Now I'm placing another truck here and another truck there. So what if the map is impossible? Like here, the red car is completely blocked. All right, so let's see. And we have a no solution pop-up. Okay, so the app knows when to stop. So that's our AI rush hour solver, complete with animation, custom maps, forest search algorithms, and a desert-style interface that's actually fun to play with. Thanks everybody for watching.